In this video, I want to focus on the mathematical topic of primes, factors, and multiples. So I'll give a brief conceptual overview of these three concepts and then go through some practical problem solving. So let's dive into the video. So I had some issues with the Save My Exams platform. So it was made premium, so I cannot access those questions. So I'll focus on and revert back to the physics and maths platform, and I'll focus on the topic primes, factors, and multiples. So if I go to the physics and math tutor platform and the problem list of regarding this topic primes, factors, and multiples, I have a lot of questions here that I'll attempt to solve. In the first part I'll try to solve some questions, but before doing that I want to just give a brief overview of the topic of primes, factors, and multiples. So if I just Google primes, factors, and multiples mathematics, just using this 4 or 5 words, I get an AI overview. So the AI overview is, in mathematics, factors are numbers that divide evenly into another number, while multiples are the results of multiplying a number by an integer. And prime numbers are whole numbers that are greater than 1 and have only two factors, 1 and the number itself. So factors are numbers that divide evenly into another number. So for 6, 3 and 2 are factors because 3 multiplied by 2 is 6, while multiples are results of multiplying a number by an integer. So one multiple of 2 can be 6 because 2 multiplied by 3 is. Prime numbers are whole numbers greater than 1 that only have two factors, 1 and the number itself, so which is very self-evident. This is the brief overview of these three concepts, primes, factors, and multiples. So I'll attempt to solve the first problem. So if I go to the question and try to solve and read the question first. So it says express 56 as the product of its prime factors. So you have to express 56 as a product of its prime factors. If I have to express a number by the product of its prime factors, what we can do is divide 56 by 2 every time and express it as a product of 2 multiplied by the rest. So for example, I can express 56 as what? 2 multiplied by 28. So 56 is a product of 2 multiplied by 28. Now I can divide 28 in the same pattern, like dividing it by 2 and then keeping the rest. So I can also represent 2 multiplied by 28 as what? 2 multiplied by 28 can be written as 2 multiplied by 14. So I can use same formula for 14 as well. Divide 14 by 2 and keep the rest. So this expression can be written as what? 2 multiplied by 2 multiplied by 14. If I break 14 into 2 multiplied by 7, I can do that as well. So 7 cannot be divided. So 7 is a prime number and 2 is also a prime number. So I can express what? I can express 56 as a product of its prime factors. So if I express 56 as a product of 2 multiplied by 2 multiplied by 2 multiplied by 7, this is the product of its prime factors of the number 56. Now I'll focus on problem number 3. So it's a very interesting one. So it says there are only blue pens, green pens, and red pens in a box. So the ratio of the number of blue pens to number of green pens is 2:5, and the ratio of the number of green pens to the number of red pens is 4:1. So there are less than 100 pens in a box. So what is the greatest possible number of red pens in the box? So what is the maximum possible number of red pens? So the ratio is given, the two ratios, the number of blue pens. Let's say if I try to solve this problem, let's say the number of what is the information given? The number of blue pens to the number of green pens is 2:5. So number of blue pens to the number of green pens is what? 2:5. This is the ratio given, and the number of the ratio of the number of green pens to the number of red pens, the number of green pens to the number of red pens is what? Is 4:1. Is 4:1. Okay, and there are less than 100 pens in the box. If I merge the ratio, because I can merge the ratio because there is a common element which is green. So how can I do that? If I multiply 5 with 4 and 4 with 5, or the first ratio with 4 and the second ratio with 5, I get what? 2 multiplied by 4 is 8, is to 20. 4 multiplied by 5 is 20, is to 4, or 4 5s are 20, sorry, 5. So I get the ratio of the total ratio of blue, green and red is what? Is 8 is to 20, 8 is to 20 is to 5. Okay, so the total in terms of ratio is what? 8 plus 20 plus 5, right? 8 plus 20 plus 5, which is 33, which is 33. And the ratio of what? The ratio of, let's say ratio is R, ratio of not green but red, I think, if I use the eraser, the ratio of what? Red, because red is what I want to figure. So the ratio of red, let's say, is what? This portion, right? 5. So 5 out of 33, if I express it in a fraction. So the ratio is 5 out of 33. And what is the maximum possible number of pens? The maximum possible number of pen can be what? Less than 100 means 99. 99 is the maximum possible number of pens that can be available. So if I multiply 5 by 33 fraction into 99, I get the maximum possible number of red pens, because red pens is 5 portion out of 33 in terms of ratio is 5 is to 33, right? 5 is to 33, because this is the 5 portion and 33 is the total portion. So 5 is to 33 is the portion of red, or 5 by 33, and the maximum possible number is 99. So if I multiply 5 by 33 with 99, I get what? 5 into 3, which is 15. So the maximum possible number of red pens is 15 out of 99. So this is the greatest possible number of red pens in the box. Now I'll focus on problem number 4, which has two parts, A and B. So in A you have to find the lowest common multiple, in B you have to find the highest common factor. So in A, if I read the problem, you have to find the lowest common multiple, or LCM, of the two numbers 40 and 56. So how do I solve it? So if I use my pen tool, so you have to find the lowest common multiple. So in order to find the lowest common multiple of these two numbers 40 and 56, we can constantly divide it by numbers like 2. So if I divide 2 with 40 and 56, I get what? 20 and 28. And if I divide by 2 again, both of them, I get 10 and 14. Then I divide by 2 again, I get 5 and 7. So 40 and 56 has basically 3 times, 2 3 times, and 5 and 7. So the lowest common multiple of these two numbers 40 and 56 would be what? 2 multiplied by 2 multiplied by 2 multiplied by 5 multiplied by 7. So it would be what? 8 multiplied by 5 is 40, multiplied by 7 is 280. So 280 is the lowest common multiple of 40 and 56. Now I have to figure out the highest common factor in the second part. So we have to figure out the HCF, or highest common factor, of A and B. So A is 2 cube multiplied by 3 multiplied by 5, and B is 2 square multiplied by 3 multiplied by 5 square. So you have to find the HCF of A and B. So if I just write down the values of A and B, so A is what? A is given as cube multiplied by 3 multiplied by 5. 2 cube multiplied by 3 multiplied by 5. B is given as 2 square multiplied by 3 multiplied by 5 square. 2 square multiplied by 3 multiplied by 5 square. So in order to find the highest common factor or HCF, what can we do? What is the lowest common ones here? So if I look at 2, the number 2 is 2 cube in A and 2 square in B. So what is the minimum? 2 square multiplied by, in terms of 3, both have common 3, and in terms of 5, A has 5 and B has 5 square. So what is the minimum? 5. So the highest common factor would be 2 square multiplied by 3 multiplied by 5, or 4 multiplied by 3, which is 12. 12 multiplied by 5 is 60. So this is the highest common factor, and this is how you can figure out the highest common factor. By now you should have a firm grasp on these 3 concepts and how you can apply in mathematics. So in the next video I'll go through some more problems regarding these 3 concepts, so stay tuned for that.